Here we have a calculus problem on the board. Okay, let's go to the information. Supplies are dropped from an helicopter and distance fallen in time t seconds is given by x equals to 1/2 times gt square, where g equals to 9.8 meter per second square. Determine the velocity and acceleration of the supplies after it has fallen for 2 seconds. Okay, now we have the equation that is x equals to 1/2 times gt square. So this is the distance equation we have, and we have to find the velocity and acceleration of the supplies after it has fallen for 2 seconds. And there is a value of for g. Actually, this is gravity due to acceleration. Okay, so we have the distance equation of supplies. Let me write the distance equation over here, 1/2 times gt square. In this distance equation, we have the value of g, which is gravity due to acceleration. That is 9.8. We can plug in 9.8 for this g. So 1/2 times 9.8 times t square. So 2 goes into 1 times, 2 goes into 9.8, 4.9 times. Then I'm getting x equals to 4.9 t square. So now the equation, the distance equation of the supplies becomes x equals to 4.9 t square. Okay, now our aim is to find the velocity and acceleration. So once we get the velocity and acceleration, then we can plug in t is equal to 2. So because we have to find the velocity and acceleration after 2 seconds it has fallen. To find the velocity, what I need to do is I have to find the derivative of the distance equation with respect to time. So okay, let me do it. So when I find velocity v is equal to dx over dt, that is I find derivative of x with respect to time. Okay, now v equals to, now for this x we can plug in this stuff, that is 4.9 times t square. So let me do it, 4.9 times t square over dt. Okay, then v is equal to, when I find derivative of this one, actually 4.9 is a constant, it is multiplied by the variable. So whenever I find derivative of some stuff where a constant is multiplied by the variable, I have to keep the constant as it is, and I have to find the derivative of the variable. So to get the derivative of this t square, I have to use the power rule. What is power rule? I just have to bring this exponent 2 in front of the variable, times I have to subtract 1 from the exponent. When I subtract 1 from the exponent 2, I'm just getting the exponent 1. So whenever there is exponent 1, we don't have to mention, we can leave it. So then I'm getting v is equal to, when I multiply this 4.9 by 2, I'm getting 9.8 t. So now I got the velocity. Okay, now what I need to do is I have to find the acceleration. So let's say a represents acceleration. To get acceleration, I have to find the derivative of this velocity with respect to time. So now in this dv over dt, so we have to plug in 9.8 times t for this v. Okay, let me do it. So d of 9.8 times t over dt. So then I'm getting a equals to, here a constant is multiplied by the variable. When I find derivative of this stuff, I have to keep the constant 9.8 as it is. When I find the derivative of this t with respect to t, it will become 1. So I'm getting 9.8 times 1. So finally, I'm getting a is equal to 9.8. So now I got the velocity, that is v equals to 9.8 times t, and the acceleration, that is a equals to 9.8. Our aim is to find the velocity and the acceleration of the supplies after it has fallen for 2 seconds. So for that, what we have to do is we have to plug in t is equal to 2 into the velocity and acceleration, what we got over here. Okay, first let me plug in t is equal to 2 into the velocity. So let me write t is equal to 2, then velocity is equal to 9.8 times. So now I plug in t is equal to 2 over here. So when I multiply this 9.8 by 2, I'm getting 19.6. So after it has fallen for 2 seconds, the velocity of the supplies is 19.6. What is the unit we have to write for this velocity we got over here? Okay, so already we know that the velocity is equal to dx over dt, and here in numerator we have x, in denominator we have t. We know that the unit of the distance given by x is meters, and the unit of time t is seconds. So we have x in numerator, so its unit is meters, that we have to write in numerator, and the unit of time t is seconds, that's in denominator, so we have to write seconds over here. So after it has fallen for 2 seconds, the velocity of the supplies is 19.6 meters per second. Okay, now let's find the acceleration of the supplies after it has fallen for 2 seconds. For that, what I need to do is I have to plug in t is equal to 2 into this one. So that is, let me write t is equal to 2, then I'm getting a is equal to 9.8. So do I find t over here? No, I don't find t. So if I find t over here, I can plug in t is equal to 2. But since I don't find t over here, so after it has fallen for 2 seconds, the acceleration of the surface is 9.8. Now, what unit do we have tried for this acceleration of the surface 9.8? Okay, already we know that x is the distance traveled by the surface is given by x. So when I find the derivative of this x, I'm getting dx over dt. So what is this one called? Actually, this is called velocity. Okay, to get acceleration, what do we do? So we find the derivative of the velocity with respect to t. Already we got the derivative of x with respect to t. I got dx over dt. So that's the velocity. To get the acceleration, again I have to find the derivative of this one with respect to time. So when I find the derivative of this one again, so I have to square this d. That is, I'm getting d square x in numerator. So what does this d square x represent? So particularly the square we have for d represents, we find the derivative of this x for 2 times. And also in denominator, I have to square t. So why should I square t? So when I find derivative of this x for 2 times, and both the times I do derivative with respect to the same variable t, so that's why I'm taking square for t. So this second derivative, second order derivative of the distance equation x gives the acceleration. Okay, here what do we have in numerator? We have x, and the unit of x is meters. So we can write the meters over here. And what do we have in denominator? We have t square. So the unit of t is seconds. Since we have t square, we have to write second square. So after it has fallen for 2 seconds, the acceleration of the surface is 9.8 meter per second square.